Good afternoon, students. So last class we saw about swapping. The next topic is contiguous memory allocation. So we know that in the main memory it is divided into two parts. One, the first part always it will be given for whom? For the operating system. The next part is for whom? For the user processes. So whenever a process need to get executed, first it should be loaded where? In your memory. Only then it will get executed. So what is this contiguous memory allocation sense? Each process is contained in a single contiguous section of the memory. So if this is the memory, if one process needs to get loaded here in contiguous fashion, say this address is 100, 101, 102, so on, in this fashion it will be there. So if that particular process size is 20 bytes, first 20 bytes in a sequential manner only it should be allotted to which process? That particular process. It cannot be splitted like here 10 bytes, here 10 bytes, like that we cannot assign memory to a particular process. So it should be assigned in what manner? In a sequential manner. That we are going to call it as what? Contiguous memory allocation. So in memory allocation we have two different ways. One way we are going to call it as what? A fixed partition. Second way is what? Variable partition. So in fixed partition it's very simple. Our total memory is there, right? User memory, user space. That memory is divided into equal size, that is equal fixed size of cells. Each cell we are going to call it as a block. Okay, see now this here it will be what? Operating system. This is the user space. Say suppose this user space is 1000 bytes. So it is divided into how much? Equal number of blocks. If I divide, say here, if I take first block is 200 bytes, remaining all should be what? 200 bytes, 200 bytes, 200 bytes. So equally it is divided here. Okay, so the total available memory is divided into what? Several fixed size partitions. So the size of each partition is same, that is it is fixed. So if this partition is 200 byte, remaining also it should be what? 200, 200. So it is equal number of fixed blocks with same size, fixed size. Okay, each process contains how many process? Each partition contains how many process? One process. Okay, see here, for example, when a program is ready for execution, see these are the programs which is ready for execution and they are kept in what? Ready queue. Say this is your ready queue. Okay, how many processes are there? 4 processes. Now P1 is selected for execution, so it should be loaded where? In the memory. So how many blocks I have told here? Totally we have 5 blocks. Okay, 1 2 3 4 5, that is 1000 bytes is there as I've given here. Now P1 is size is how much? 170 bytes, but it is assigned to which block? First block, 200 bytes. Similarly P2, 50 bytes is the second block is assigned. That size is also 200. Even though the memory is space is getting wasted, it is, since the size of each block is fixed, each process occupies one block. That we are going to call it as what? Fixed size partition. See here, in third P3, size is what? 110. So third block will be given here. See, this is P1, this is P2, this is P3. Okay, each size is what? 200 bytes. Now P4, what is the size? 250. But what is my block size? It is 200. Do we have a block size above 200? We don't have. So what will happen? No memory is allocated. This is called as what? Fixed size memory allocation. So as I've told here, see, one more point. The number of processes that can run at a time depends upon what? The number of blocks in the memory. How many blocks we have in the memory? Totally we have 5 blocks. So at a particular time, maximum 5 processes can execute simultaneously. Say if I have 10 blocks, 10 processes can run simultaneously. So it depends upon number of blocks. If blocks are 5 processes. If blocks are 2, only 2 processes can run at a time. When a process terminates, when a process terminates, that particular block of memory becomes what? Free, and it is kept in what? Available for some other process.